Geometry Semester 1, Lesson 5.6, the study of secants, tangents, and proofs. A secant is a line or segment that passes through a circle at two endpoints. A secant angle is an angle formed by two secants intersecting outside the circle. Make note of outside. Outside is going to be very important. All right. Okay. Using the circle that's given, it says intersecting secants. Our two intersecting secants are going to be secant AC and also EC. The secant angle is just our angle C that's created on the outside. Or you can call it angle ACE, or it could be angle BCD. Or you can write those in reverse order. The intercepted arcs, or the arcs that's created, AE, and BD. The secant theorem says that the measure of a secant angle is half of the difference between the measure of the two intercepted arcs. Let's move ahead and practice. Okay, so in the given example, we have two arcs given and we need to find out the measure of angle ACE. So as long as you remember that the angle, when you have two secants and the angles on the outside, the angle is equal to the big arc minus the small arc, all divided by 2. That's where the difference come in. So the angle, I don't know what it is, but I know my big arc is 100. My small arc is 20. So I find that difference and divide it by 2. So my angle is just going to be 80 divided by 2. So my angle is going to be 40 degrees. So that means angle C is 40 degrees. We'll do the next circle the same way, but we're trying to find the measure of the smaller arc, BD, highlighted. So once again, we start with what we definitely know. The angle is equal to the big arc minus the small arc divided by 2. So my angle is actually given this time. It's 48. 48 is equal to my big arc, which is 223, minus my small arc. I don't know what it is, so I'm calling it X. All divided by 2. So a quick way to get rid of that fraction is to put 48 over 1 and cross multiply. So 48 times 2, we get 96 is equal to 223 minus X. I would subtract 223 on both sides, and I would get negative X is equal to a negative 127. Well, since the degree won't be negative, I'll just go ahead and divide everything by negative 1. So X in this case equals 127 degrees. So that means my angle right here is equal to 127 degrees. Now, a tangent is a line or segment that intersects a circle at exactly one point. A point of tangency is the point where a tangent meets a circle. And we're going to talk about tangents. T-A-N-G-E-N-T. Where a tangent meets a circle. All right, and the point of also it's good to know that the point of tangency and a radius make a 90-degree angle. So when you see tangent, think 90-degree angle. All right, even if the box isn't there. So here are some basic rules. Looking at this circle here, and just as a review, this is circle C, named by the center. Blank is tangent to circle C. So our segment is AB. AB is our tangent to circle B. The point of tangency is just where it touches, is D, and the radius in this case is CD. A tangent is perpendicular to the blank that shares the point of tangency to the radius. That's what goes on this line here. Boom. And there we go. But once again, like I said, that 90-degree came up again right there. So when you see tangent, think 90 degrees. By definition, a tangent chord angle is an angle formed by a tangent and a chord of a circle that's intersecting. The rule is the measure of a tangent chord is going to be half the measure of the intercepted arc inside it. So right here, you would just put half. All right. So, for example, the measure of angle ABC is going to be half of the arc. So, if ABC is half of the arc, you take 86 divided by 2, and you get 43 degrees. That means this angle right in there is 43 degrees. And likewise, the measure of the arc AB, if the angle ABC is 63 degrees, then we times it by 2, and we get the arc is equal to 126 degrees. And that's it. Okay, this one I had some extra stuff because I ran out of space. It says a definition of tangent angle is an angle formed by two tangents intersecting outside a circle. So right here you would have two tangents intersecting outside a circle. The rule is the measure of a tangent angle is half. Let's just say half. Oops, that don't look good. Half of the difference between the measure of its two intercepted arcs. So not much different there. Big arc minus the small arc. Okay? Between the measure of its two intercepted arcs. Okay, so in looking at the picture that we have here, which is circle O and circle O, the intersecting tangents are going to be the AB, that segment touching the circle in one spot, and BC, which touches at one spot. So the tangent angle is angle B, or you can call it angle ABC, or you can write it backwards as CBA. The two intercepted arcs is the major arc, which is ADC, and AC, the minor arc. The next page asks you to find a measure of AC, and to find a measure of AC is very similar to what we've been doing. AC is an arc, so I know that the angle is equal to the big arc minus the small arc divided by 2. So my angle I know is given is 60 degrees, and so that's equal to 240 minus my small arc. I have no idea what that is, so I call it X divided by 2. Once again, to get rid of the fraction, put 60 over 1 and then cross multiply. 60 times 2, 120 equals 240 minus X. I would subtract 240 on both sides. And I would end up with 120 equals, that's the negative 120, equals negative X. So X in this case, once you divide both sides by negative 1, you would get 120 degrees. So that means this arc right here is now 120 degrees. And then it asks you for the measure of angle OAB. Well, this one is kind of easy because AB is a tangent, and a tangent touching a radius will always, every single time, make a 90-degree angle. So angle OAB is 90 degrees, just like angle OCB is also 90 degrees. Okay? And that's it. Have a nice day.